With the second video of the WireMock series, we now will take a look at the several features that WireMock offers and that help us testing our applications. So in case you haven't watched the first lesson yet, make sure to take a look at it, because this video now builds on top of the first lesson, as we are going to explore the features of WireMock based on our sample setup. One of the first things we will take a look at is the request matching capability of WireMock. So therefore, let's write a new test and let's call it WireMock request matching. So for now, I will copy here our test. So what we have done so far in the first video, we really hard-coded here the HTTP URL, which we internally know that we are going to fire a request for this particular URL. But WireMock also allows to provide here, for example, a regex. So in case we are not quite sure or also don't want to hard code here the URL, or might add dynamic query parameters, for example, timestamps, which we can't place in here for the test setup, we can use WireMock and say here, for example, also any URL. So here any URL would match or would be served this response, but that's not what we want. So here, WireMock, what I wanted to show here is the URL matching method, and then inside here we could now provide an URL regex, which WireMock then internally will use to determine if it should serve this stub for this particular request. There is also one URL equal to, which we also implicitly used before. So where we said with this /todos, once WireMock receives a call for this particular endpoint, please return exactly this stub. So let's do here a different URL. So let's say we stub here the response for users, and if we now run our test, we will see a test failure. So first thing is our Spring Boot application returned 500. So something internally was wrong. And if we take a closer look at our application, so we will see here our web client returned 404. So this to-dos endpoint here wasn't actually mapped from us inside WireMock. So because here we put in users, so that's for sure. And also what WireMock does on test failure, which is quite important to understand what went wrong, it prints out this ASCII table here, which explains that an incoming request couldn't be matched. And here we see this was the request, and the closest stub WireMock currently has inside its in-memory list of stubbings was for users. But as these two doesn't match, I mean the HTTP method here would match, but as this is not a regex or something more generic, WireMock can't serve the response for exactly this request, and hence WireMock returned the default 404. It returns whenever it can't find a stub. We can also modify this default 404 that WireMock returns if we want to. So before we fix this, I want to show you one functionality of WireMock we have to keep in mind when reusing WireMock. So for now, as we see, we first stubbed here the to-dos endpoint as part of this test. So these stubs are not exhaustive. So once they are served by WireMock, these stubbings will still remain inside the WireMock server. So if we have a test set up where we first stub something and then execute the next test, the subsequent tests will also use those WireMock stubbings if we don't reset them. So I want to showcase this with a small trick here. So I've annotated the test with JUnit Jupyter's test method order. So I want to take full control of the order our tests are executed. And if I say order 1 here and order 2 here, this test will now run first. We'll add a stubbing for to-dos, have here the success as this is working as expected. But then our next test where we are expecting, so if I put in here is 5xx, because that's what we have seen, because we only stubbed here users. If we would now run the entire test suite, we will see here our last test now failed, because even though we are stubbing here /users, WireMock returns 200, and that's because internally it still has the stubbing from the previous test and it wasn't removed by us manually, and WireMock won't do this out of the box. So that's why here we have to keep in mind, in case we are using a WireMock server multiple times and reuse it for multiple methods, that we have to take care of resetting the stubs inside WireMock, because otherwise we would have side effects between the different tests, which we clearly want to avoid. And therefore what we can do is, inside before each, we can clear the WireMock stubbings, so it will be reset to the default. So what I want to showcase here first, let's say stored stubbings. So with WireMock, we can also request the list of stubbings it has internally configured. So therefore we can say get stub mappings and can say here, as this returns a list, let's take a look how many stub mappings we have. And then you will use here the reset all. You can also particularly just reset the mappings. With reset all, we will also reset the requests. So we will later see that we can also, after we executed the test, ask WireMock to retrieve all the requests that arrive to make further investigations about, for example, the HTTP body in case we are performing post requests or ensuring that the headers were present as expected. But for now, let's reset everything and then copy this indicator here to check that afterwards the resets are down to 0 again, because each of our tests should start with a clean WireMock state to avoid any side effects. It's also what we see here now. So our last test is now again returning 500 because the stub mapping here didn't match. And we have this nice output here before each test. So we will see here, before we actually executed the WireMock request matching, there was one stub mapping stored inside WireMock, and this was exactly from our other test method. And after resetting it, it's down to 0 again, and we can start with a clean state. While our demo application is quite simple, there might be more complex test scenarios where we have multiple HTTP calls for a particular use case we are testing. In case we also have to provide stubbings for the same endpoint, because for the business processing is called multiple times, we can work with a priority. So one thing we have to understand is, let's do this here back to a correct stubbing matching and copy here the proper expectation. So WireMock will serve, in case it finds for the same endpoint 2 stub matchings, the one that was stubbed the last. So if we would here first stub here a successful response, but the second stub will be a failure. So let's say here we're returning HTTP status code 500 for the exact same endpoint. And if we will run the test now, we will see that our test failed because, as mentioned, WireMock will use the last stub that was stored for this particular URL. And in this example here, it was the 500. If we swap the stubbing setup, so now the OK response comes last, we should see our test becoming green again, because this now takes priority. Now it's back to green. So in case this ordering is not sufficient, we can use the priority and therefore add this add priority to our stubbing setup. So the highest priority is 1. So let's put in here 1, and for the failure, let's put in 10. So now if we re-execute the test, we should see a successful test case, because even though this was stored inside WireMock last, this one here has a higher priority. And with that priority, we have more control in case we have conflicting or duplicated mappings for the same URL and want to really prioritize one stub for a particular test case. And that's also what we see here as part of our log output for the test. So the test is now back to green because WireMock internally served this instead of the 500. So right now we haven't returned any valuable data yet, so just a empty JSON array. With the next test, I want to showcase how we can actually return something more meaningful, or an actual JSON array with more data. So therefore, let's say we rewrite this here to with data. We can remove the priority because for now we just return one stub. And then as part of our test, let's say we are expecting here now 3 JSON elements as part of our JSON array. And instead of hard coding here with body, so as already mentioned, if we would have access to the text block feature, we could put in here a nicely formatted JSON array, but we don't have access because here we're using Java 11. But WireMock offers a with a body file method, and there we can specify the file name, and by default WireMock will recognize any files inside this __ files folder inside source test resources. I've added an additional subfolder, so in case we have multiple APIs, so for example a to-do API, a PayPal API, a weather API, we could have different folders, and inside these folders we can now store different responses. So here I've put in a sample response, which is actually mirroring the response we are getting from the remote system. So here we can then also, for example, duplicate it and say big response. So in case we want to test when the remote system returns, I don't know, 500 JSON elements, then we could have here a different response, or we could also test corner cases in case values are missing or undefined. So therefore we can add multiple JSON files to this folder structure here, and then inside our test we can refer to them with their folder names. So we don't have to specify __ files because this is implicitly added by WireMock, but now we have to say we want the response 200.json, and in this way outsourced the content definition of our response to a file inside our project. And if we re-execute the test here, we will now see a green test. So with this JSON path expression, we check that the response has exactly 3 elements. We can also add further expectations here, for example, to really make sure it's the JSON response we just saw there. So therefore, let's say we are accessing the first element, and then I want to take a look at the title. And then here I'm saying this should be equal to this string. So this is here a valid JSON path expression. And if we re-execute the test, we will see the test is green. So WireMock is actually returning here the JSON which we stored inside our file system. And with this way have really fine control about the responses, can pick responses from the production system, or in case we are fixing a bug for a particular response from a remote system, we can put it in here to store it and have further tests make sure that the bug is gone. One final capability of WireMock I want to showcase is that we can get access to the actual request that arrived at the WireMock site. So for now, with our HTTP GET, there's not much to check because we don't pass any data. But in case we are having a web client that also makes an HTTP post to a remote API and, for example, creates an entity, we want to ensure afterwards that the body we passed alongside the request is valid, or we want to introspect any HTTP headers that were passed alongside the request. And for this verification part, we can use the WireMock server and say verify. And with this verify, we can now say how many times we expect, for example, the HTTP GET to arrive at WireMock. So for our test, it's just 1. And then we have to specify which request. And in our example, it's the /todo. So we want to verify that we really made an HTTP call against this URL. So even though we already have here an implicit checking because our test would fail if we would make a different HTTP call, it's still for some use cases helpful to do this verify, especially when we want to check HTTP headers or the body, because as a next step, we can say with header, for example, and then can now make assumptions that our client passed the accept header, and then can here use the equal to and say we are expecting that our client requests JSON data. In case we have some further headers, we can also check them here. So for example, let's say we assume our client passed the XAuth header and passed here Duke, for example. So we will see this will fail later on. Or in case we are sending data alongside a request, for example, for an HTTP post, we can now use here with request body and make assumptions about the request to ensure, for example, we are passing the correct JSON or XML payload. As we are not doing this for our request, we can simply drop this here. And with this verification step, we can re-execute our test. We'll see a test failure because we were expecting the XAuth header, which wasn't present because we only provided here the accept header. We could now, if we would also perform TDD here, now adjust it and then here add a further header, for example. Let's implement it quickly. So for this particular call, we will add the XAuth header to our call and then rerun the test. And we'll now see a green test case and could verify that our HTTP client really made the request as we are expecting it. Furthermore, if this verify part is not sufficient for our verification, we can also get the entire list of all serve events, how WireMock calls these. And with this list, we have access to all serve events where WireMock served a stubbed response for an incoming request. And for example, we can now inspect here the first serve event because in our test case, we know we are just making one request. And then we can get, for example, access to the request or the response. So also this way, if we now say get request, then we can say, for example, here contains header and could also do the additional check here. Or if we want now also really get access to the body to make further assertions, for example, with JUnit or SRJ, can say here get body as a byte array or as a string to then ensure that the request body we sent alongside our application's request is exactly what we are expecting. So this way we can get more detailed information about the request and can make further assumptions in case this .verify doesn't serve our needs. Furthermore, also might be important for some verification steps inside after each. We can also ask WireMock how many stubs couldn't be served by WireMock and where it returned the default 404. So therefore we can get access to find all unmatched requests. And for our test case, this should be 0. We can make here an assertion about this. So we are expecting that all requests were matched with at least a stub that we provided and WireMock didn't fall back to any default behavior. And let's ensure this also programmatically here. And test is failing because this returns a list and I was already ahead and wanted to check the size. So let's add size here. And now I have a green test case and could here verify first that the request was coming in exactly how we expected. Also get more granular access to the request if we take a look at the serve events and then inspect the request for each particular serve event, and are also able to check if WireMock was really able to satisfy all incoming requests and there were no unmatched requests. So with this basic introduction to WireMock, you should be now able to tailor your responses to your needs. So we saw how we can stub HTTP responses for different requests. We saw then here we can fine tune the status. So we can put in here any status we want. We can say here also our authorization was false, or in the worst case also that the server is down or currently inaccessible. All this can be tweaked here and also tailored to our needs for each particular test case. And there's also one final thing I want to show. This is the fixed delay. So we can also simulate a quite long waiting time for our application. So here it's in milliseconds. So I'm saying this response now takes 1 second to return. And with this fixed delay can now simulate slow responding remote systems and also check that our application, for example, in case it's taking too long, falls back to a default behavior and cuts the request or any other mechanism or business logic we put in place in case it's taking too long. As part of the next video, we will take a look at how we can simplify the setup a little bit when using JUnit 4 and JUnit 5. As right now we're doing it the manual way. We are always starting and stopping the WireMock server for each of our tests. So if we are just having one integration here, that's quite fine. But imagine this application grows and we need the WireMock server for multiple tests. We would add this logic here over and over and add quite some boilerplate code to all our tests, which can be avoided if we are using either rules for JUnit 4 or an extension for JUnit 5, which we will take a look at in the next videos.